My name is Benjamin Turner. I'm a reseller of Star-CFD in North America. I'm going to show you how to do a static mixer. Let's see. First, I'm going to create a static body here. I'm going to go down to primitives and pipe. I'm going to pick this bifurcation pipe. Click OK. Alright, now we've got a pipe in here. Now, since it's a parametric object, we can go in here and fiddle with all the different parameters. Let's change out here. Okay, that's a little long. That wasn't the one we wanted. I think we wanted to change length 1 here. Alright, look at that. So we're going to have a scalar in here, fluid coming out the end. Okay, next we need to create some inlets. Let's rename this pipes, create inlet. We're going to select this edge over here, that one. We're going to flip direction, okay. We're going to rename this one inlet 1. And here I'm going to change the velocity to 0.5. I'm just making up this stuff as I go here. So when you have open systems in Lattice Boltzmann, you always want to use a gentle ramp. You don't like impulse to the system. We're going to turn on pressure filter as well. That'll help remove any pressure oscillations. I'm going to duplicate this, and we're going to rename this inlet 2. Okay. Now I'm going to choose the edge over here. This edge, flip the direction. Okay, so now we have a second inlet. Inlet 1, inlet 2. I'm going to make this one a little bit faster, and then I'm going to have an outlet. So let's go to create outlet. I'm going to choose, you can just choose a point on the bounding box for that one since it's aligned with the bounding box. Okay, and then I'm going to rename this one outlet, and I'm going to adjust it pressure type to pressure. So that's going to be an outlet. All right, what's next? First, we need to make sure that our lattice is lined up right. So we're going to preview the lattice. So we're going to do it like this. Compute preview. Uh-oh. It says we can't find the lattice. Why is that? Because our point most likely is outside of it. So we click up here, move. See, it's down here. That's right. So we want to move that in the middle. We don't do meshing in Lattice Boltzmann. It's based on voxelization. So let's preview our lattice again. From the top, compute preview. Voila, there we go. Look at that. All right, close. So what's next? Now we want to set up our simulation here. I'm going to use the ILES turbulence model. It's a little bit better for this type of analysis. And we didn't have a ton of lattice points. So I'm going to click up here. Just kidding, it's on main lattice. Nope, it's on simulation parameters. Reference Y. That's how many points we're going to have across this dimension of the box. See, it's set to 16. That's a little low. I'm going to go to 50. And then now if we check our preview lattice again, click on Y, compute preview, we should see much more lattice points. Great, perfect. See how quick that was? Imagine how long that would take to mesh. All right, so now we got one coming in here, one coming in here. If we click up here, you can see that this is set to water. It starts out as water, kinematic viscosity and density here. Let's add a scalar. So I'm going to create a scalar, and this is what we're going to use to mix. Okay, so it's asking us here, where do you want to inject the scalar? I don't want to inject it anywhere this time, so let's skip that, rename this injected scalar. Sure, why not? Our base unit's moles, diffusion coefficient is basically water. Sure, let's lower it a little bit so we get more mixing going on. Our initial background is 0. Okay, here's where we want our to specify our inlet. So let's do our inlet on inlet 1, and this is in moles. So let's say it's 0.3 moles coming in. Specified inlet 2, none. We don't have any inlet coming in there, and our specified outlet here for the outlet is going to be 0 gradient. Okay, because that means whatever happens happens. Okay, let's save that. All right, now we should be injecting a scalar. It's going to ask me where you want to save this. I'm going to save it locally. I'm just going to create a temp folder here on my hard drive. I don't want to save it to the network because it would be super slow. All right, so let's solve this and see what happens. You can see here I'm just using a 4090 desktop GPU. There's nothing really fancy about this. We're solving. We're going to ramp up. Let's see what happens here. So the only number you really need to track in Lattice Boltzmann is this one, minimum max LB density. This is a measure of the local compressibility error. If this gets too high, that means the fluid's moving too much in a one time step. You know, technically it's the current number. We seem fine here. So let's click on post and see what's happening. You can see here that the injected scalar is changing. I'm going to shrink this post a little bit so you can see it once it loads here. And so yeah, we're literally viewing the simulation as it's running. Here we go. Let's go over here. All right, so that's our pipe coming in. Two things. One, you'll notice that it starts off not turbulent, so we probably want to change that. The second thing is, well, that's mostly the main thing. Okay, so in Lattice Boltzmann, we don't have a synthetic turbulent entry point. Okay, so here you see it starts off laminar and ends up being turbulent down here. So if we go back to the beginning and watch this, you can literally watch it form, and every time I click this button, I get more time steps here, this one. So if I click here, you can literally watch it become turbulent. Okay, but we assume that upstream is turbulent. So let's go back and make that a little better. I'll show you how to do that. First, I want to check our scalar here to make sure scalar stuff is happening. All right, look at that. Scalar stuff is happening. You see it's happening poorly though, because this isn't mixing at all, is it? Okay, no it's not. So let's go back over here. I'm going to stop this. You can see we're already 3 seconds into it. So the best way in Lattice Boltzmann that we have right now to make a turbulent inlet is to add a region that makes turbulence. What are you talking about? Well, let's just add a torus here. So I'm going to go back over here to primitives. We can choose a sphere or a torus. I'm going to choose a torus. Why not? Drop that one in here. It comes in down there. I'm going to change its shape to 0.05. And again, I'm making this up on the spot here, so cut me a little slack. And we're going to rotate this by 90 degrees. Okay, and then we're going to move it where we want it. We want to move it up here to the inlet. I still think it's too big, so I'm going to adjust the shape here, 0.03. And again, I'm just eyeballing this, 0.01, because all we're trying to do is we're trying to create some turbulence, right? Let's move this up here, over here, this way, that way. Now I'm going to rotate it a little bit so it's kind of in the middle of that pipe. Just click OK, and then I'm going to click rotate from the top. Let's give it 45 degrees. Okay, so now this is our turbulator, basically. It's going to come in here, it's going to turbulate. Perfect, let's have 2 of them. Duplicate, 1 for each side. All right, let's move it over here. Right there, but it's not the right orientation, so rotate it. And CMStar has all these tools that you can use to rotate this stuff in here. It's really easy. Okay, well that's not right, Ben. Rotate, global direction Y, 90, boom, there we go. Okay, now we have scalar coming in here, just water coming in here, and we're going to watch this flow develop around that. So let's save this, solve that, click that, yes, and away we go. Yes, we want to remove the existing files. Off we go to the races. Okay, let's see what happens. Now we've added some turbulence. Let's see if we have any problems with the LB density as we ramp up. Looks good right here. We want to be between 0.96 and 1.04, 4% compressibility error, and we don't have that at all. So if you look down here, this is the inlet pressure for both of these to conform to that velocity that we've defined. This is the outlet pressure. This is the scalar field. You can see that things are happening and the concentration RSD is dropping, which implies that something mixing is happening. So let's click post. Look at that. See, now that we have some turbulence being created. Remember, we have 2 different velocities. So here we come in, we turbulate. This is more realistic. So if you ignore this part of the pipe, right, this is how we get the fluid started, get it turbulated. Like I said, we don't have a synthetic turbulent boundary condition, but you can just add a torus or a sphere and it does the same thing. A rotated box, there's all sorts of different things you can use. Of course, you can change your colors here for the directors that you want to astonish. Let's click on our scalar injection here. Now we can see what is our scalar doing or lack thereof. Okay, so if we look from the top, right, here's the scalar coming in. Not mixing great, is it? And every time you click this button, you're getting more time steps. The crazy thing is this is so fast. I'm on a desktop and we can literally simulate a static mixer as we're watching it. Okay, well that sucks, Ben. Let's fix it. Okay, go back over here, stop this. I'm going to add just a twisted thing in there. Okay, so let's go to I'm going to go back to my pipes. I'm going to add geometry on top of this, and then down my primitives here, And there should be a twist somewhere. Twist, twist, twist. Where did we put it? Where did we put it? Here it is. It's under miscellaneous. Twist element. All right. Static mixer. Click OK. See, he's too big, so let's reduce it to our width here. 0.05, I think, is the right one. Perfect. And let's give it one twist. Let's reduce the thickness. Let's make it a little longer. Sure. And let's move it down here. All right. Now let's see what happens. Let's check our lattice real quick. We should see the lattice in the middle of it. Compute preview. Ah, see, I made a mistake. The fill point is now inside of that, so I need to move it. Move it down here. It's a volumetric fill point. There is no meshing, so to speak, but we do have to put it into free space. Now we should see, look at that. See, now it works. See how it's going around that? So this should mix. Now close this, save that, click solve, delete whatever's there. Yes, I want to do that. Run. Yes, I'm sure. Off to the races. Mixing is occurring. Check our LP density looks good. You can see our inlet pressure has gone up, which is what you would expect because we have literally something blocking the flow now. But we weren't talking about optimizing the pressure drop. We were talking about creating a static mixer. So then click post here. Let's view what's going on. Pops up. I'm gonna switch to 2D just because it's prettier. Click plus Y. All right, look at this. We've got turbulator here working. We've come swapping around this. You can see it twisting around this twist element here. Let's change the colors for our directors. Let's go back to the beginning. All right, now let's look at our scalar. See how our scalar looks. Oops, on the wrong slice. I mean, much better. I got him looking at it from the wrong direction was previously. There we go. But this is obviously much better than it used to be, right? So that's MStar. It's a static mixer in 5 minutes on the phone. I mean, I didn't even practice this. Okay, I lied. It's 12 minutes, but I didn't practice this. I just freestyled it because MStar is that fast, that capable on desktop GPUs. There's nothing like it. Thank you.